back to sequences. We've done just a little bit of work with sequences. We basically talked about the difference between arithmetic and geometric, but today I want to get a little bit more into the terminology. So here we go. So when we say n, here's what we're referring to. We're talking about the number of the term. Like the first term, the second term, the third term, the fourth term. When we say a sub n, like this, we're referring to the value of the nth term. Or the value of term n. So if we said a sub 1, we're talking about the value of the first term. If we said a sub 2, we're talking about the value of the second term. If we say a sub 100, we're talking about the value of the 100th term. All right, so we're going to see that a little bit here in these few examples. What is the seventh term of the sequence? So what is the seventh term? Okay, well, let's look at what kind of sequence we got going on here. We're adding 3, and then we're adding 5, and then we're adding 7. So let's keep this going here. Let's add 9. We're adding consecutive odd integers here. And that would give us 25. And then let's add 11. And that would give us 36. And then let's add 13. And that would give us 49. And that would be the seventh term of the sequence. 1, 2, 3, 4, 5, 6, 7. Okay, the terms of the following sequence are generated with this Fourier formula, and this says the value of the nth term is equal to 5 times the number of the term minus 2. Okay, and find the 10th term. Well, we see here that the first term is 5 times 1 minus 2. And the second term is 5 times 2 minus 2. I mean, they gave us this formula, and it's working for the numbers that are in this sequence. And the third term is 5 times 3 minus 2. That's 15 minus 2 is 13. See, that matches up. And furthermore, the fourth term is 5 times 4 minus 2 equals 18. Okay, this is all useless work that I've done so far. Or maybe I should say that the fact that they gave me the first 4 terms of the sequence was not necessary by them. They gave me this formula, and that's all I needed. If I want to find the 10th term, all I need to do is plug 10 into that formula. The value of the 10th term would be 5 times 10 minus 2, which is 48. And that's really all they were asking, okay? So I didn't need to do all this work. I'm just kind of proving it to you. They didn't need to give me this sequence here. They gave me the formula for the sequence. That was good enough. Which formula below generates the following sequence? Okay, so which one of these will give me 0, 3, 8, and 15? Well, let's just do this by trial and error, I think would be our best bet. So on this first one, the value of the fourth term should be 4 minus 1, but that's 3, not 15. It's supposed to be 15 for the fourth term. So A is straight out. It doesn't work. What about the second one? 2 times 4 minus 1 should give me 15, but again, that gives me all right, what am I doing? What am I doing here? The value of the fourth term would be 4 minus 1 in this formula here, and that gives me 3, not 15, so that doesn't work. On this one, I get 8 minus 1, which is 7. But again, I wanted it to be 15. I'm sorry. Let's fix that. So that gives me 7. All right. But again, I wanted it to be 15, so that one doesn't work either. Let's try C. The value of the fourth term should be 4 squared minus 1, and that is 15. So it looks like C is our answer here. Let's try a couple more just to make sure. The third term should be 3 squared minus 1. That's 9 minus 1, which is 8. Yep, that works. And the second term should be 2 squared minus 1. That's 4 minus 1, which is 3. And yep, that works. I think at this point we know that the answer is C and not A or B. We could plug in 0 squared minus 1. I'm sorry, 1 squared minus 1 would be 1 minus 1, which is 0. And that works for the last one too. Sorry, got a little mixed up there. We trudge on. What are the first 4 terms in the sequence generated by the following formula? Okay, so they give me a formula and they want me to find the first 4 terms. No problem. The value of the first term is 1 squared plus 2 times 1 plus 1. So that's like 1 plus 2 plus 1, which is 4. So there's my first term. The value of the second term would be 2 squared plus 2 times 2 plus 1, which is 4 plus 4 plus 1, which is 9. The value of the third term is 3 squared plus 2 times 3 plus 1, which is 9 plus 6 plus 1, which is 16. And the value of the fourth term, because they wanted the first 4, would be 4 squared plus 2 times 4 plus 1, which is 16 plus 8 plus 1, which is 25. So the first 4 numbers in the sequence are 4, 9, 16, and 25. All right, next they're asking us, can we write another formula that generates the first 4 terms in problem D? If yes, write a formula. Well, let's look at these first 4 terms. We got 4 squared. We got 4, 9, 16, and 25. So what do we notice about those? Well, I noticed that they're all perfect squares. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared, and 25 is 5 squared. So there's got to be an easier formula. How about this? This is going to take a while for you guys to get good at here, but again, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So those are the numbers in our sequence. So how about if we go like this? The value of the nth term is equal to, we can't do just n squared, but we could do n plus 1 squared. That'll work because we want to take the number of the term. First term is 1. Add 1 to it, that would be 2, and 2 squared is 4. The second term, add 1 to it, that would be 3, and 3 squared is 9. And jump into, say, the fourth term. The fourth term, we put a 4 in for right here, and 4 plus 1 is 5, and 5 squared is 25. So that works. Find the 20th triangular number. Well, it's going to be difficult for you to know if you don't know what a triangular number is. So here's the triangular numbers. 1, 3, 6. Those are triangular numbers. See this pattern? If we just keep making these patterns with dots, we get triangular numbers. 10. Let's do one more here. And 15. Those are triangular numbers. So we want to find the 20th one. Probably the easiest thing to do would be to make a formula. I'm not going to make you make it. I'll just give it to you. There's the formula for the triangular numbers. Write that down. Maybe make a note too. This is the formula for the triangular numbers. You take the number of the term, multiply it by the number of the term plus 1, and then divide by 2. So if we want to find the 20th triangular number, here's all we got to do. We'll just do 20 times 20 plus 1, all divided by 2. In other words, 20 times 21 divided by 2, which is 210. So the 20th triangular number is 210. Now, the formula is a lot easier, I think you'd agree with me, than actually going out here. We've only done 5 triangular numbers, and you can see how complicated that's getting. Just to do one more would be pretty difficult. We don't want to keep doing this, so we'll just use this formula that I just gave you, and reference back to it anytime you're asked about triangular numbers. All right, that's it for today, and we'll practice this tomorrow. I'll see you then.